In this last part of section 7, we're going to look at a word problem and how we would apply something like one of these inequalities with two variables. So let's take a look at this one. You're going clothes shopping and can spend at most $130. It costs $30 for a pair of pants and $22 for a shirt. Write and graph an inequality that describes the different numbers of shirts and pants that you can buy. Well, we know that it costs $30 for pants and $22 for a shirt. We don't know the numbers of pants and shirts we're going to buy, so that's what's going to be our two variables. So an X is going to be the number of pants that we buy, and the Y is going to be the number of shirts. So that makes our inequality. If pants are $30 and there's X pairs, so that's going to be a 30X. And then shirts are $22 and we have Y shirts, so that's a 22Y. We of course want to add those together, and we can spend at most $130. So at most means that the most we can spend is $130. So we can spend anything up to and including $130, which means that the amount we spend on pants and shirts needs to be less than or equal to $130. So this is our inequality. Now we want to graph it. And because we're talking about pants and shirts, we only care about this graph in quadrant 1 because we're not going to buy a negative number of shirts or negative number of pants. And so we only need the quadrant 1. And so down here we're going to label our pants, and then on the side here, shirts. Okay, and now to get our scale we need to know what we're going to graph. And this is in that standard form, and so the easiest way to graph standard form is to find the X and the Y intercepts. We should remember back from chapter 4 that you graph X and Y intercepts. You find those by plugging in the zeros. So we're going to plug in 0 for X and solve for Y. So that gives us 22Y, because 30 times 0 is 0. 22Y is less than or equal to 30. Divide both sides by 22. And we have Y is less than or equal to 130 divided by 22 is 5 and 10/11ths. And now we do the same thing, but plugging in Y, or 0 for the Y. So we have 30X plus 22 times 0 is less than or equal to 130. 22 times 0, of course, is 0. So we divide both sides by 30, and we get X is less than or equal to 130 divided by 30 is 4 1/3. So now we can go ahead and do our scale. We can, of course, count by ones. And so on our x-axis, we're going to put a point at 4 1/3. So here's 1, 2, 3, 4, and a third of the way past 4. And then 5 and 10/11ths is almost to 6. So here's 1, 2, 3, 4, 5. We're almost to 6. And then we're going to draw the line connecting them. It's a solid line because it's less than or equal to. And we're going to shade all of this below that line because it was a less than. So now we've written our inequality and we've graphed it. Now part B says give 3 possible combinations of pants and shirts that you can buy. Well, one of the fallbacks that most of us have used in questions like this in the past has been using the X and Y intercepts as possible combinations. But this case that won't work because our X and Y intercepts are both fractions, and you can't buy a fraction of a shirt or pair of pants. And so we need to find the whole number combinations that are going to work. And if you would graph this line on a grid, you would actually notice that none of these points on the line actually fall on those nice even grid lines that would represent a whole number combinations. But this is an inequality. We're not spending just $130, which is what the line represents. We can spend anything up to and including $130. So any of these points in this shaded area that represent two whole numbers are going to work. So for example, we've got a point here at 1, 1. So one possible combination would be one shirt and one pants. We also have 2, 1. So that could be 2 pants and 1 shirt. We could have a point up here at, let's say, 2, looks like 2, 3. So that would be 2 pants and 3 shirts. And as we get close to this line, we'd want to double check. This one's a little close, and I just did a rough sketch, so I'd want to check. Pants, of course, were $30, so 2 times 30 is 60. Shirts are $22, so 3 times 22 is 66. 60 plus 66 is 126, so that's still under our $130. We've got a couple of other possibilities. We've got 1 pant, 2 shirts, 1 pant, 3 shirts, 1 pant, 4 shirts would work. 1 pant, 5 shirts, because this right here is actually 1, 5 probably would be off of it. So any of these points in here, and of course graphing on a grid would give you a better idea and using a ruler to draw your line. But as you get closer to that line, you want to make sure that you substitute the numbers into your inequality, and just to make sure that they are going to work.